If you look at YouTube videos of people using brain-computer interfaces, the most exciting demonstrations of prosthetic control communication are with a 1989 device called the Utah Ray, developed by BlackRock Neurotech. And just to think that everything that's been done over the last 20 years in this brain-computer interface technology for assistive communication, prosthetic control, really data intensive, has been bandwidth limited by this 1989 device. Think back in time to what the internet was used for in 1989. Because brain-computer interface of the type that, let's say, Paradromics, Neuralink, BlackRock are conceiving of, is fundamentally a modem for the brain. So it's like you look at how modems were used in 1989, and then what happened in the modem industry is that modems got twice as fast every 2 years or so. And then as the hardware got better, instead of having purely text-based internet, suddenly you can load images fast enough. And the way that people use the internet changed. In 2010, I like to give the example, Netflix changed from a company that mails people DVDs to a company that does real-time streaming. It wasn't like some genius Steve Jobs moment, but fundamentally enough people had enough download rate that you could have a business that streams video. For me, what's happening in BCI, high data rate BCI right now, is that you have Paradromics and Neuralink in particular saying, okay, yeah, we're going to build a device that is 10x higher data rate, and then we're going to go build one that's 100x higher data rate, and then 1000x higher data rate. And you're going to see an expansion of what is possible, applications that are possible, that kind of mirrors the development of the internet. And so it's like there's this mixed strategy where you have really kind of pragmatic companies that are building the best possible therapies with the technologies that exist today and helping millions of people. And then you have companies that are trying to build the enabling technology to sort of bring more branches down so that there's a new sort of crop of low-hanging fruit to be harvested. And I think that you're going to see an expansion as what is possible as the data rate for accessible architectures increases. That will necessarily involve power consumption, because digitizing data is power hungry and transmitting data is power hungry. And so, I think what we'll do is we'll get better, just like modems, that probably the modem in 1989 that was really shitty drew the same amount of power as the one that I'm using right now. And so like, as you get access to better technologies, you can do more with less. But there's never going to be a situation where we dial this back to like a nanowatt and you can do megabits per second.
I think you hit the nail on the head when you said that the power consumption of a computer that was, my Pentium 286 is not all that different from the power consumption of my laptop today, right? But it does so much more. So I completely agree with you. We're going to see performance 10x and 100x. Both in data rate. I think we're going to see therapeutic performance 10x and 100x. But I think the power consumption is going to creep up a little bit, but I don't see it 10x and 100x in power consumption.